are your 401B notes. Graphing quadratic functions, we're going to look at the quadratic as a maximum or minimum value. So yesterday we explored how you graph a function, and then today we're going to talk about whether that quadratic represents a maximum value or a minimum value. Different than a line, a quadratic or a parabola will start up and end up, or it'll start down below and end down below. So if it starts up and ends up, this bottom point is where it minimizes. The graph will no longer go below that point. So that is a minimum point on the graph. And then same thing over here, just the opposite. If it starts down and ends down, it's going to max out at a particular spot, and no point will ever be higher than that. So that's called a maximum point of a graph. Lines don't have that because a line continues forever upward and downward, and so there is no max or min. So when you have this, in order for a parabola to open upward, that means that the a value is greater than 0, or that a is positive. So if the a value is positive, it's going to open up, and if the a value is negative, it's going to open down. Sort of really similar to slope. So your a value of these things is just like the slope of a line. Positive, it's going to rise. Negative, it's going to fall. Same thing with absolute values. When we had that positive number on the outside, the v opened up, and it was negative on the outside, it went down. So the same concept is going to apply here. And so from that sign, we can determine whether it's going to be a maximum or minimum. We don't actually have to graph these, but what we can say is, in theory, what would it look like? And so would it be a maximum or a minimum? The maximum or minimum value is the y-coordinate of the vertex. So after you find the vertex, you might have a vertex. The x-coordinate tells you how much it went over to the left or to the right. The x-coordinate produces the min or the max value. So in this particular case, depending on whether this was opening up or whether this is opening down, if my vertex is at 320, 20 would be the maximum or minimum value. Now 320, that ordered pair, can have two different parabolas stemming from it. If it was a 320 vertex with a parabola opening up, then in this case, 20 would be a minimum value. So I know we think up, and we think going up means max, but the point we're talking about is the bottom of that parabola. That is the minimum point. No y value will be lower than 20. That's what you're saying there. If 320 was the top of my parabola, which it could happen, then in this case, the 20 in there would be a maximum, meaning that no y value will be higher than 20. All the other y values will be lower than 20. So we're not going to graph today, we're just going to interpret what that means. So if we can find the vertex, which we know how to do algebraically, we can find the min or the max. So for number 1 here, I can see that my a value, the a value is the value out in front of the quadratic term, the squared term. A is equal to a positive 1. So if it's a positive 1, my parabola would look like this. So I'm just going to draw a little sketch of it. My parabola will be opening up because it's positive, and so that makes this point a minimum value. It's at the bottom of the graph. That's all the graphing I'm going to do, is just a quick sketch to see in my head that the vertex would be the very lowest point on the parabola, and then we can go from there. So now that I've identified that it's a minimum, I have to find the minimum, and that entails finding the vertex. So I'm going to use my x equals negative b over 2a. That means x is equal to the opposite of b over 2 times a, which is 1. X is equal to 4 over 2, which is equivalent to 2. So my vertex would be 2 something. Now I got to find the something. To find the something, we take that 2, we plug it into the equation everywhere we see the x, and we solve. So I have 2 squared minus 4 times 2 plus 9. That's 4 minus 8 plus 9. And when I put that in my calculator, I get 5. 4 minus 8 is negative 4, plus 9 is 5. So my vertex is 2, 5. They didn't ask for the vertex. They want you to interpret the vertex that that's the lowest point. The 2 shifts us to the left or to the right. The lowest point, the minimum value, is 5. So the answer to this is we have a min, and where is it? At 5. I have a minimum value of 5, which means all of my y values on that graph will be greater than 5. 5 is the smallest number on that graph. For number 2, you can see that the a value is now a -1. And I like to change this. I like to write it as a y equals -1x squared. I'm noticing that I'm missing a b value. So I'm just going to put in a b value of 0. So now I have all my parts. So the -1 tells me that my parabola is going to be opening upside down. Okay, and so this point at the very top is the maximum point. So whatever value I find for my maximum tells me y values will never go above that value. So now I got to find my maximum value. Again, I'm going to use x equals -b over 2a. X is equal to, well, my b value is 0. That's why I like to put it in there if it's missing. 2 times -1, but 0 divided by anything is just 0. So I'm not done yet. I have my vertex is 0 something. It's the something I need to find. To find that y coordinate, I plug 0 in for x into the function everywhere I see it. So y is equal to -1 times 0 plus 0 times 0 plus 7. And in this case, everything's going to disappear, and my maximum value is also my y-intercept. It's 7. So the max value here is 7. Okay, I don't want to see the whole vertex. I want you to interpret what that means. Take the part of the vertex we need. Okay, 0 is the value that makes the maximum 7. 0 is how much we move over to the left or to the right to give us the maximum. But the maximum value is 7, and what that is saying is that there will be no y values greater than 7 on this graph. I skipped the word problem. We can do it together in class tomorrow. It's a little bit involved, and so I figured it'd be a good way to just kind of start the class period. It tells you why would we want to know this. So it gets a little bit involved. I don't want to lose you too much, but it makes sense in real life when you would want to maximize or minimize something. So for tonight, you just need to determine whether the following quadratic has a maximum or minimum value. Don't have to do anything. You should just be able to look at that and tell me that answer. And then the practice problem, I want you to find the minimum value for the function. Good luck.